we get to the nicest module in Unit 2, which is Module 3. So getting to Module 3, it says, how many numbers made up of 5 digits can be made from the digits if each number contains exactly one even number and no digit is repeated? So it must contain one even number and no digit is repeated. All right, so first thing I like us to do is underline the critical information. You want to make a 5-digit number and it needs to contain exactly one even digit, and no digit is supposed to be repeated. So if it contains one even digit, that means we need to choose a 2, a 4, a 6, or an 8 after the end of the number. So let's look at those different cases. So let's go with case 1, that the even number is 2. So let's go with case 1, the even number is 2. In case 1, if the even number is 2, you have 5 digits, 1, 2, 3, 4, 5. All right, if the even number is 2, you must choose 2. So it don't matter which part you put the 2, 2 just there in the number, right? So I'm going to say we already take out the number 2. So that's one number that we choose. Now there should only be one even number. So that means we cannot choose 4, we cannot choose 6, we cannot choose 8. So that left us with 1, 3, 5, 7, 9, 5 other numbers to choose from. So because we have 5 other numbers to choose from, right, it's going to be 5 times 4 times 3 times 2. All right, so this number right here, if I were to put it, this is number 2. All right, if we take number 2, then the 5 numbers that we can choose from right here is either 1, 3, 5, 7, or 9. Those are the 5 numbers we have what we can choose from. All right, these are the 5 numbers left. Because we definitely cannot choose 4, 6, or 8. All right, that's why. And so in this case, for case 1, as you realize, in case the even number is 2, there's going to be 5 factorial ways. 5 times 4 times 3 times 2 times 1 is 120. So there's 120 possibility. Let me see. 5 ways to choose here. 5 times 4 times 3 times 2. 5 times 4 is, let me just put it in my calculator. 5 times 4 times 3 times 2 times 1. Yeah, that's 120. So there are 120 ways we can choose the number. We can choose the number 2 with 4 other digits. All right, nice. Now let's look at case 2. Case 2 is when we choose a different even number. Let's say we choose number 4. Case 2, we choose the even number 4. Since we choose the even number 4, right, 4 is the only even number that will be there. In case 2, you choose the even number 4. So that one put on already. So since you choose 4, you can't use 2, you can't use 6, you can't use 8. So you're left back with either to choose from 1, 3, 5, 7, and 9. So there are 5 ways you can choose the next number. 5 ways. Then there are 4 ways the third number. Then there's 3 ways. Then there's 2 ways to choose the last number. This is still 5 factorial again. That works out to be 120. So pretty much what that is telling me is all the 4 cases, I'm going to get 120. So case 4, case 3 rather, case 3, is choosing the number 6, and that's going to be 120 as well. And case 4 is going to be choosing the even number 8, and choosing the even number 8, we're still going to get 120. So what does that mean? That means that adding up all of them is going to give us, so number of 5 digits with one even number is equal to, number of 5 digits with one even number is 120 times 4, which is, put that in my calculator, 120 times 4, 480. That's the number of 5 digits that we can get with one even number and no digits being repeated. Now it says determine the probability that this number formed is less than 30,000. If the 5-digit number is less than 30,000, that means the number either start with 1 or the number start with 2. Make sense? Okay, I can have a number like 12,000 something, or 20 something thousand, 15,000, 18,000, and something of that sort. And so let's look at case 1. Case 1 is where the 5-digit number starts with 1. So if the 5-digit number starts with 1, in case 1, the 5-digit number starts with 1, that means it will definitely choose 1. All right. The second issue is that it must have been an even number. So let's say the even number in this case is 2. Let's say we choose the even number 2. So there's only one way we can choose the even number 2. So that means we can't choose number 2. We can't choose 4, 6, or 8. And so if we can't choose 4, 6, or 8, then we're left back with, remember, you know, we choose number 1 is taken out already. We're choosing the even number 2, and so we can't use 4, 6, or 8. All right, so those are 5 numbers gone. We're only left back with the other numbers to choose from. So we have the number 3 can choose from, 5, 7, 9. All right, because we cannot, 1 already gone, 2 already gone, and we cannot choose 4, we cannot choose 6, we cannot choose 8. So we're left back with 4 numbers can choose from. And then right here, so we're going to have 3 numbers can choose from. Then the final digit, we're going to have 2 numbers can choose from. So 4 factorial, that's 24 ways. That's 24 ways we can choose a number 1 with the even number being 2. Now let's look at, what if we chose the even number to be 4, right? All right, so this was the case where the even number was 2 and we start with 1. This was the even 2. What if we wanted the even number to be 4? If the even number is 4, we're still starting with the number 1, which there's only one way. And if the even number is 4, then it wouldn't be 2, still one way. And if we choose even number 4, we're still left back with 4 other numbers can choose here, 3, and 2. Nice, so this is what we have. So it's still 4 factorial, which is 24. So pretty much what I'm getting then is when the even number is 6 and when the even number is 8, you're still going to get 24 and 24 ways. So that's for case 1. All right. Now let's look at case 2. Case 2 is if the number start with 2. So case 2 is that the 5-digit number starts with 2. If the 5-digit number start with 2, then that means we can't use any other even number. So the 5-digit number start with 2. There's only one way that can go. One way, it start with 2. Then that means we have 2, 4 out, 6 out, 8 out. All right, and so we're left back with 5 other digits can choose. 5. Then 4 digits can choose here. then 3 digits can choose here. 1, 2, and then 2 digits can choose here. So this equals 5 factorial, which is 120. So finally, the probability that the number chosen above, that the number is less than, let's say 30,000, that's what they want. The probability that the number is less than 30,000 is going to be equal to the total amount of numbers less than 30,000, which is 24 plus 24 plus 24 plus 24, which is 4 times 24 plus 120, and this is divided by 480. And this is divided by 480. So you work that out now. So 4 times 24 plus 120 divided by 480, that's 0.45. That's the probability. So there's a 45% chance that the number is going to be less than 30,000. 45% of the time. Nice and easy, soft. So there's a 55% chance the number is going to be greater than 30,000. All right, part B. Part B says that A and B are two matrices that are given by or given as, okay, so given as this and this, and let's just get to the meat of the matter. They want us to find the value of x so that A inverse doesn't exist. A inverse will not exist if the determinant of A is equal to 0. So we need to set the determinant of A to the 0. The determinant of A is going to be using what they call this again, column. Using column 1, it's going to be 2 times 0, 2, 1, and 0 minus 3 times x minus 1, 1, let me see, cross this, so it's 1, 0. Then we have plus 2 times and we cross this across, we have x minus 1, 0, 2, x minus 1, 0, 2, and we'll set this equals 0. So we go ahead and we're going to work this out now. So working this out, what we're going to be getting is 2 times 0 times 0 is 0, minus 2 times 1 is 2, minus 3 times x times 0 is 0, minus 1 times 1 is minus 1, so it's minus 1, which is plus 1, plus 2 times x times 2 is 2x, minus 0, that is equal to 0. And so we go ahead and simplify. 2 times minus 2 is minus 4, minus 3 times 1 is minus 3, plus 2 times 2x is 4x, and that is equal to 0. And so what we're getting is minus 4 minus 3 is minus 7. So I'm getting 4x equals 7. And so x can equal 7 over 4. So just to finish it off, x is equal to 7 over 4. That is the value of x for which A cannot have an inverse. So just to check it again. Yep, that looks good. 0, 2, 1, 0, that's fine. This is x minus 1, 1, 0, that's fine. And this is x minus 1, 0, 2. So we're good here. Good. Now it says, given that the determinant of A b is equal to minus 10, show that x is equal to 2. So first thing I'm going to do is I'm going to work out what is the matrix A times B. Well, you don't even need to do that. The determinant of A times B is then telling us that the determinant of A times the determinant of B is minus 10. So the determinant of AB, we can always remember that the determinant of AB is the determinant of A times the determinant of B. The determinant of A times the determinant of B is minus 10. Now, the determinant of A, if you were to write this as a formula, the determinant of A would actually be given by, this would have been minus 4. Determinant of A is given by minus 4. Going back around here, then it would have been minus 3, minus 4, minus 3. And going back here, it's going to be plus 2 times 2x, which is plus 4x. So the determinant of A is given by minus 4 minus 3 plus 2x. All of this is going to be multiplied by the determinant of B. And the determinant of B we can find. Let's do it right here. Determinant of B would be 1 times 2, 5, 3, 4 minus 2 times let's go here now, cross this and this, we get 2, 5, 1, 2, we get 2, 5, 1, 2, we cross down this now, and we go here now, cross this, go here, and we cross this out, and we're getting 2, 3, 2, 1, so it's plus 2 times 2, 3, 2, 1. This is to find the determinant of B. So what this is working out to be is, we can work this out now. We're going to get 2 times 4 is 8. 8 minus 15 is minus 7. So this part works out to be minus 7. Then this part now works out to be 4 minus 5. 4 minus 5 is negative 1. And negative 1 times minus 2 is plus 2. And this part works out to be 2 times 1 is 2, minus 3 times 2, which is minus 6. So 2 minus 6 is negative 4. Negative 4 times 2 is negative 8. So what we're getting is negative 7 plus 2 is minus 5. Minus 8 is negative 13. This is minus 13. Nice and easy, that's minus 13. Now that we get minus 13 here, yep, so the determinant of B is minus 13. This is equal to negative 10. So this expression is really 2x minus, is it 2x or shouldn't it be 4x? 2x times 2, yeah, this was supposed to be 4x. This was supposed to be 4x. This was supposed to be 4x. So the expression is now 4x minus 7 times 13. So 4x minus 7 times 13. All right, I'm just going to put a bracket around it and put minus 13. That's equal to negative 10. So I'm going to divide through by minus 13. And I am getting that 4x minus 7 is equal to And I divide through, I am getting, what's that? Minus 10 over, let's go again. When I add that, I would get this times this. If I were to expand it in, let's just expand it in. That would be minus 52x. Then minus 13 times 7, I think that's 91. That's plus 91. And that's equal to negative 10. I bring over the 91 by subtracting 91 from both sides. And I get minus 10 minus 91. That's minus 101. And that's giving me minus 52x. I divide through by 2, I'm getting 1 point something. What went off now? Is the determinant of A right? Just checking to make sure this is right. 2x, this is 4x. This is minus 1 is plus 1. Minus 3. This part is definitely minus 3. And this times this is 0. 0 minus 2. All right, where did we go? All right, where did we go? Just checking the determinant of A formula. We know it should have been, this is 2, AD minus BC. This is minus 2, that's minus 4. This part is now AD is 0, minus 1 is 1, minus 3, minus 4, minus 3 is minus 7. And this is 2x minus 0 times 2, that's 4x. That's 4x minus 7. This part is right. And check the determinant of B. The determinant of B, let's go again. Determinant of B would have been using column 1, it's going to be 3. Using column 1, it's going to be 3, 4, 1, 2. Cross this, 3, 4, 1, 2. I see the mistake now. 3, 4, 1, 2. My apologies, right here. 3, 4, 1, 2. Something was off. Should have been 3, 4, 1, 2. Let's just check to make sure the others is correct. Using this 2, it would have been 2, 5, 1, 2, yes. And using the last one, it would have been, this here would have been 2, 5, 3, 4. It would have been 2, 5, 3, 4. How did I get these numbers? That's crazy. Have to be very focused. 2, 5, 3, 4. A lot of mistake was made there. Oh gosh. My gosh. Working out the determinant of B again. This would have been 6 minus 4, which is 2. That would have been 2. This would have been 4 minus 5. 4 minus 5 is minus 1. Minus 1 times minus 2 is plus 2. And this would have been 8 minus 15. 8 minus 15 is minus 7. Minus 7 times 2 is minus 14. So the determinant of B is actually negative 10. It's actually negative 10. The determinant of B is actually negative 10. All right. Determinant of B is actually negative 10. Okay. Now I can feel a little more relaxed now. This should be negative 10. And so I didn't need to do this step. I could just divide through by negative 10. Then I'm going to get 4x minus 7 is equal to 1. So divide through by minus 10, I'm going to get 4x minus 7 is equal to negative 10 over negative 10 is negative 10 over negative 10. So I'm getting 4x minus 7 equal 1. And if 4x minus 7 is equal to 1, then I can bring over the 7 to the other side. And from this, clearly, x will be equal to 2. Finally, nice and easy, soft. Nice question. Continuing. It says, hence obtain A inverse. It says hence, meaning given that you know this. Given that you know this, then what you do know is that if the determinant of B was 10, then we know that the determinant of A, we now know that the determinant of A is equal to 1. If the determinant of A is equal to 1, then what that means is, if the determinant of A is now equal to 1, then that can help us to find the value of x in this. Since the determinant of A is equal to 1, and that is telling us that 4x minus 7, which was, oh, we just found x now. We said that x was 2. And so since x is now 2, we now know the matrix A with the determinant being 1. And so now we know that A inverse is going to be equal to 1 over the determinant of A times the adjoint. So all we need to do is find the adjoint of A. And the adjoint is the cofactor matrix transposed. So I'm just going to write what was A again up here. I'm going to go look back and write down A around here. So we have it right here. So A was 2x minus 1. 2x minus 1. So A is 2x, which is 2 minus 1. And so the next was 302 and then 210. 302, then 210. So let's go ahead now and find A inverse. So it's going to be 1 over the determinant of A. Determinant of A is 1. 1 over 1 is just 1. So all we really need to do is find the adjoint. And the adjoint is the cofactor matrix transpose. I'm going to put T up here. We're going to find the cofactor matrix. Plus, minus, plus, minus, plus, minus, plus, minus, plus. All right, nice and easy. So let's go ahead now and do this question. Going ahead and do this question now, as we can see right here, to find the cofactor for this element, it's 0, 2, 1, 0, 0, 2, 1, 0. Cofactor of this element will be 3, 2, 2, 0, 3, 2, 2, 0. Then the cofactor of this element will be cross here, wham, wham. That will be 3, 0, 2, 1. Just want to make sure. 3, 0, 2, 1. Let's expedite the process a little bit. Cross here. We're going to get 2 minus 1, 1, 0. That's 2 minus 1, 1, 0. For this one now, it's going to be cross here, 2 minus 1, 2, 0. That's 2 minus 1, 1, 0. All right, going for the final one here, it's going to be cross here, it's 2, 2, 2, 1. So it's 2, 2, 2, 1. Down here now, it's going to be cross here, it's 2 minus 1, 0, 2. This is 2 minus 1, 0, 2. Going right here now, it's going to be cross here, it's 2 minus 1, 3, 2. It's 2 minus 1, 3, 2. And right here, it's going to be cross here. It's going to be 2, 2, 3, 0. 2, 2, 3, 0. The final one, 2, 2, 3, 0. I just want to check this one right here. Something look weird about the second one. Cross here. It's 3, 2, 2, 0. Just wanted to make sure. So now that we have the cofactor matrix, we can go ahead and simplify it. And so we're going to get that A inverse is equal to, working out this is 0 minus 2 is minus 2. This is now 0 minus 4, minus 4 is 4. This is now 3 minus 0 is 3. This is now 0 plus 1, and the minus of plus 1 is minus 1. Then we have 0 plus 1. Then we have 2 minus 4. That's minus 2, but minus 2 make it positive 2. Then we have 4. Minus 0 is 4. Then we have 4 minus 3 is 7. Then the minus, that makes it minus 7. Then we have 0 minus 6. That's minus 6. And remember, we need to transpose it. Let's transpose it. So transposing it, we get that A inverse. Finally, we get that A inverse is going to be minus 2, minus 1, minus 4, and that's going to be 4, 1, minus 7, 3, 2, and minus 6. Nice. Okay, continuing right along. Part C. Part C says, in an experiment, individuals were asked to select from 2 available colors, green and blue. The true individual selected 1 color, 2 colors, or no colors. 70% of the individuals selected 1 color, 600 individuals selected no color. All right. Now, if you were a person that like to think diagrammatically, or you like to see what's happening like myself, you could draw a set and you can say either you select this your color, or you select another color, or you select both colors. We can call the intersection for the amount of people that collect both color X, and it tells us that 600 don't select no color, so 600 don't select no color. The 2 colors are green and blue, so we can call one set green and one set blue. And it tells us that 600 people is 30%. So by calculation, 0.3 times the total amount of people is equal to 600. And so if you divide both sides by 0.3, that gives you the total population. And the total population in the school, if it's a school choosing colors, it's going to be X is equal to 600 over 0.3 is 2000. X is 2000. All right, nice. If X is 2000, that means that the universal set is 2000. And it said 70% selected at least one color, meaning that this total in here sum to 1400. That means 70% is 1400. All right, that means in here this sum to 1400. All right, so what they're telling you is 0.7 times X is 1400. All right, now next thing it tells us is that 40% selected green and 50% selected blue, meaning 40% of individuals selected green and 50% selected blue, meaning 40% of the total population, so 0.4 of 2000 selected green, and so 0.4 times 2000 is 0.4 times 2000, that's 0.4 times 2000, that's 800. So that means 800 minus X selected green only. And then the next thing is that it says 0.5 of the total population selected blue. 0.5 of 2000 is 1000. So 1000 minus X selected blue. Now we need to find X to know what this intersection is. So you can go now and say that 1000 minus X plus 800 minus X, that is equal to 1400, because the total amount in this set sum to 70% of the population. That's 1400. Cool. So what that means is 1000 plus 800 is 1800 minus X, that's equal to 1400. So that means that X equals 400. X equals 400. X being 400, what does that mean for us? X being equal to 400 means that 400 person. So X equals 400. That implies that 400 persons selected both colors. So figure out all of the information now and let's attempt the rest of the question. It says calculate a probability that an individual selected both colors. So the probability that is select two colors, probability that a person select two colors, well, that is just going to be equal to how much people select two color? 400 over the total school campus, which is 2000. So 400 over 2000, that will give you 400 divided by 2000, that's 0.2. That's the probability of a person selecting both colors. Now you might say, sir, I didn't want to do it like that. That was too long. There was another way you could do it. Yes, another way you could do it is this. Remember the formula. The probability of green intersect red, it's equal to the probability of green plus the probability of red minus the probability of red intersect green minus the probability of red union green. You might say, sir, why you didn't do it like this? I could. So the probability of green intersect red would have been equal to the probability of green 0.4 plus 0.5 minus the probability of red union green, which is 0.7. That's what they told us. And you would get 0.2. So you might say, sir, why you never just do that from the start? No, this way, it shows the examiner you understand exactly what you're doing. This way, it's just the formula. Come on, man. This don't show me that you understand nothing. This show me that you know what you're doing. Nice. Now it says determine the total number of individuals that participated. 2,000. We found that already. So this was 2,000 persons. We already show it around here. Nice. All right, we'll finally get to the best question on the paper. Question number 6, which is going to be differential equations. So this question says, a differential equation is given by x dy by dx plus y, and that's equal to 2 sine x. Show that the general solution to the differential equation y is equal to c over x minus 2x over cos x. Nice. Okay, let's go ahead and do this. Okay. X dy by dx plus y is equal to 2 sine x. So let's go ahead and do this nice and entertaining question. All right, so let's go ahead. Why is it not zooming? Having some difficulty here. Let's try that one more time. Okay, all right, finally. Now we may proceed. So to do this, first you want to divide through by x to get it in the form dy by dx. When you divide through by x, you're going to get plus y times 1 over x, and that's equal to 2 sine x over x. All right, and then what is the first thing you need to do? Find your integrating factor. Your integrating factor I is equal to e to the integral of 1 over x. E to the integral of 1 over x. When you integrate 1 over x, you get ln x, so it's e to the ln x. E to the ln x is just x. Nice. So what do you do next? You find your general solution. So your general solution now, let's call it GS. Your general solution is going to be y times your integrating factor x, and that's equal to your function of x, which is 2 sine x over x times x. 2 sine x over x times x, and we're integrating all of this with respect to x. Dx. Now the x times the x cancel. This cancel this. And so what you get is y times x is equal to the integral of 2 sine x. The integral of 2 sine x is 2, integrate 2 sine x. Integrate sine, you get minus cos. So it's going to be minus 2 cos x plus some constant c. Then all you need to do is divide through by x. Yep, so good. We divide through by x, and so this implies that divide through by x, we get y is equal to, let's start with the c part first. C over x minus, divide this part by x, we get minus 2 over x times cos x. Nice and easy, soft. So finish that question now. There it is, nice and easy, soft. That takes care of this part, soft. It says now, hence, determine the particular solution of the differential equation that satisfies the condition y to be equal to 2 when x is pi. So y is 2 when x is pi. So that means that we're going to substitute y as 2 and x as pi. So substituting it, y is 2 and x as pi. Plug in x as pi, it's going to be c over pi minus 2 over pi times the cos of pi minus 2 over pi times the cosine of pi. That's equal to the cos of pi, the cos of 180, which is the cos of pi, and the cosine of pi is minus 1. So this becomes minus 1 times this, which is c plus 2 over pi. And so c plus 2 over pi is equal to 2. We cross multiply to get 2 pi minus 2, and that's equal to c. So since that is c, therefore, what I'm going to do is factor out the 2. Let's write c as 2 times pi minus 1. This looks better. Let's write it in a prettier form as 2 bracket pi minus 1. So if this is c, what we're going to get is y is equal to c. Y is equal to c over x. So y is going to be 2 times pi minus 1 over x. 2 times pi minus 1 over x minus 2 over x cos x. Nice and easy, soft. All right, now part B. Part B says, show that the general solution of this differential equation is given by that. Okay, to do that question, let's write it down. We have dy by dx, and dy by dx is going to be equal to x times y. Dy by dx is x times y minus y over x squared minus 4. This is dy by dx. Nice. So let's cross multiply. Well, not cross multiply yet. Let's factor out y. We're going to factor out y, and what we're left back with is x minus 1 over x squared minus 4, and that is now dy by dx. And now what we're going to do is we're going to divide both sides by y and cross multiply dx. So what we're going to get is 1 over y dy is equal to cross multiply up dx, and we get x minus 1 over x squared minus 4 dx. Aha, now we can integrate both sides. But before we can integrate both sides, I can't integrate this like that. I need to rewrite this now. Instead of x squared minus 4, I'm going to write it as x minus 2 times x plus 2. I'm going to rewrite it as x minus 2 times x plus 2. But wait, I noticed that x minus 2 times x plus 2, and I have a x minus 1 in the numerator. I can separate this part using partial fraction. So I'm going to have to separate them using partial fraction. So let's separate them using partial fraction. Now, using partial fraction, we're going to get that x minus 1 over x minus 2 times x plus 2, separating using partial fraction. What we're going to get is that this is equal to some constant over x minus 2, some constant over x minus 2, plus some constant b over x plus 2. So since this is what we get now, what we can do now is separate them. We can separate them now to find a and b. Now the LCM would be x minus 2 times x plus 2 and so we're going to get a times, this is x plus 2, sorry. So we're going to get a times x plus 2 plus b times x minus 2 and that's going to be equal to, of course, x minus 1 over x minus 2 times x plus 2. Now, of course, when you get to this stage now, what you are going to have to do is equate the numerators. Whenever two fractions are equal, you equate their numerators. Equating their numerators, well, let x be 1. If we let x be 1, or let x be 2. If x be 2, 2 minus 2 is 0. And if x is 2, this is x minus 1. I'm writing rubbish here, trying to move a little faster. X minus 1, x plus 2. If we let x be 2, substitute 2 here, we get 2 plus 2 is 4. So we get 4a is equal to 1. And so that then tells us that a equal a quarter. A equal a quarter. And then if you make x be minus 2, you get minus 4b. You're going to get minus 4b is equal to x being minus 1. X being minus 2 rather. X is minus 2. We get minus 2 minus 1 is minus 3. So you have minus 3 is equal to minus 4b. And so that tells us that b is equal to 3 over 4. So that is b. b is 3 over 4. Since b is 3 over 4, we can proceed. So now what we're going to get is, continuing from right here, let me block it out. This is not necessarily part of the solution. This is just workings. So what we're going to say now is, this part where we have 1 over y dy, that part where we have 1 over y dy is going to be 1 over y dy is equal to, continuing, we have around here, x minus 1 over this is going to be a over this, and a over this is a quarter over x minus 2. So a quarter over x minus 2, I'm going to rewrite that as a quarter is 1 over 4 into x minus 2 plus 1 over, it's not 1, it's b, and b is 3/4 over x plus 2 dx. This is what we have now. Since we have all of this now, we could multiply through by 4, because I don't like the quarter thing. Let's multiply through by 4. I'm just going to multiply through by 4 to write 4 over y dy, and that's equal to, that's going to become now 1 over x minus 2 plus 3 over x plus 2, and it's all of this dx. So now that this is what we have, what we can do is now integrate both sides with respect to y. Integrate both sides with respect to y. Integrating both sides with respect to y, what you're going to get is 4 over y dy. When you integrate that, you can factor out the 4. You're going to get 4 ln y. You're going to get 4 ln y is equal to the integral of 1 over x is just ln x minus 2 plus, when you integrate 3 over x plus 2, you get 3 ln x plus 2 plus some constant of integration c. You get plus some constant c. But now look at this now. Instead of writing some constant c, I'm going to bring up the power of 4 and write this now as ln y to the 4 is equal to ln x minus 2. I'm going to bring up the power of 3 to write plus ln x plus 2 cubed ln x plus 2 cubed, and then this 3 right here, I'm going to put it as plus this c right here, I'm going to write it as ln a, or let's write it as ln k. Let's write it as ln k. ln k is still a constant, c is just ln k. Now by laws of logarithm, we can write these as 1 log. So we're going to write it now as ln log a plus log b plus log c is a log of abc. So this is now just a log of x minus 2 times x plus 2 cubed plus, or times, ln k is just times k. So now that I have everything as 1 log on that side, and that's ln y to the 4. Now apparently, well, the logs apparently cancel, or that's what they have been telling us, that logs cancel. And so the log cancel to leave that y to the 4 is going to be equal to, y to the 4 is equal to x minus 2 times x plus 2 cubed times some constant k. Let's put the constant in front. So to find y, you just take the quart root. So taking the quart root, you're going to get y is equal to the quart root of, put the quart root, so you put a 4 to show that it's a quart root. Y is the quart root of k times x minus 2 times x plus 2 all cubed. That's how you do this question. nice and easy and simple and soft. That is why. Nice, soft. Well, the k is on the outside right here. So what you can do is use surds and break up this as the quart root of k times the quart root of this. Since that's how they want their answer, we can break this up then as the quart root of this, the quart root of this, times the quart root of our k, times the quart root of our k. All right, and then this quart root of our k, we can just call that answer some small k. All right, so now this is just some small k. This is capital K, this is small k. And so y is now k times, because it's still a constant. Quart root of k or k still a constant. So y is just now k times the quart root of x minus 2 times x plus 2 all squared. Nice and easy, soft. Nice. Proven. Now part C. Part C says solve the boundary value problem. It says that y double prime minus y prime minus 2y. Solve that boundary value problem. Now to solve that problem, 10 marks, whoa. To solve this boundary value problem is 10 marks. Now to solve this problem, first we need to do is solve the auxiliary equation. Its corresponding auxiliary equation, I like to call auxiliary equation AE. The corresponding auxiliary equation will be u squared minus u minus 2 is equal to 0. And then you go ahead and factorize this. You go ahead and you factorize it. And so you get u. Solving this characteristics polynomial has to be 2 and 1. Signs are different, the greater product negative, so minus and plus. So what you're getting is u is equal to minus 1, or u is equal to 2. U is either minus 1 or u is 2. So since this is what we get now, so the general solution, which is our complementary function, I like to call it YC. So the general solution is going to be, because we get two different roots, it's going to be AE to the minus 1 times x, which is minus x, plus BE to the 2x. But the thing is, we need to find A and B, because they said given that when x is minus 1, y is 1. So when x equal minus 1, what we're going to get is y is 1. So putting y as 1, we're going to get 1 is equal to A. And they say x is minus 1. So minus 1 is 1. So you get A e to the 1. So you get AE. Minus 1 is just 1. So you get AE plus. X is minus 1. So you get BE to the minus 2. BE to the minus 2. Alright, so you get one equation. This is when x is minus 1. That's one equation. Now when x is 1 now, so when x is 1, we're going to get a different equation. When x is 1, y is 0. So you're getting 0 is equal to put x as 1 here, so you get x is now 1, you get ae to the minus 1, and then x being 1 here is also 2 times 1 is 2, so plus be to the let's go, be to the x has 1 here too. So we need to solve these two equations for a and b. All right, so to solve these two equations for a and b, this is what we're going to be solving, these two equations. So let's see the easiest way to do this. The easiest way I'm seeing is if I to make a the subject from, let me see, make a the subject from here. All right, let's make a the subject from this one. From this one, I'm going to make a the subject, so I can use substitution. I'm going to get 1 minus b e to the minus 2 over e. That's going to be equal to a. That's what I get when I make a the subject from here. 1 over e, we can say that is e to the minus 1. 1 over e is e to the minus 1 minus b e to the minus 2 over e is b e to the minus 3. That is a. So a is e to the minus 1 minus b e to the minus 3. Substitute that in here for a now. So I'm going to plug it into this equation. And so the output it's going to give me now is, substituting it now, I'm going to get 0 is equal to e to the minus 1 minus b times e to the minus 3. And this is being multiplied by e to the minus 1 plus b times e squared. So this will allow me to solve for b. So now expand this now, e to the minus 1 times e to the minus 1. When you work that out, you're going to get, when the bases are the same, you add the powers. Minus 1 plus minus 1 is minus 2. So I get e to the minus 2. Then I add the powers again, minus 1 plus minus 3, I get times be to the, adding the powers, minus 3 plus minus 1 is minus 4, plus be squared. All right, so I'm almost finished. We are almost done. What we can do now is bring over it over here to get, we're going to carry over. So let me just write back the equation. We have 0 is e to the minus 2. 0 is equal to e to the minus 2. And we had minus be minus be to the minus 4. And we have plus be squared. All right, so let's go now. So let's go. We need to make b the subject. So bring over this to get minus e to the minus 2. Then we're going to factor out b from this side. Factor out b. We're going to be left back with e squared minus e to the minus 4. Then we divide both sides by that, and so this implies that b is going to be equal to minus e to the minus 2 over e squared minus e to the minus 4. Because I don't want the minus in the numerator, I'm going to put it in the denominator. So I'm going to rewrite it as e to the minus 2 over e to the minus 4 minus e squared. I just put the minus in the denominator. Now since this is b now, I already had a formula for a. So a is going to be equal to, going back around here, we said a was 1 minus b, a was e to the minus 1 minus b e to the minus 3. So a was e to the minus 1 minus b e to the minus 3, which is minus, this is b now, e to the minus 2 over e to the minus 4 minus e squared times e to the minus 3, that is a. And so what you can do is, since the bases are the same, we add the powers to get e to the minus 1 minus, this will become e to the minus 3 times e to the minus 2 is e to the minus 5 over e to the minus 4 minus e squared. And so you can make it one fraction now, make it one fraction by multiplying this times e to the minus 1. So when the bases are the same, you add the powers, making it one fraction, you get e to the, add the powers, minus 1 plus minus 4 will be minus 5. So you get e to the minus 5, e to the minus 5. Add this power, minus 1 plus 2 is plus e to the 1 minus e to the minus 5 over e to the minus 4 minus e squared. Now you might take a look at it and say, oh, e to the minus 5 cancel e to the minus 5, you're right, and e to the 1 is just e. So a is e over e to the minus 4 minus e squared. Now, I don't know how you prefer to write it. So if you like this as a decimal, you can put these as decimal. Just put it in a calculator and write them as decimal. You can write them as decimals. Putting this as a decimal, it is e to the minus 4 minus e squared. And then e divided by that. In this, I'm getting minus 0.4 or 0.37. And up here, I am getting e raised to the minus 4 minus e squared, and e raised to the minus 2 divided by the answer. I'm getting minus 0.01 for b. I'm getting minus 0.01. Minus 0.018. And this was actually minus 0.37. So depending on how you want to write your answer, if you want to write them as decimal or as a whatever, up to you. I like to write it exact, so I'll work with the exact form. And so now remember the solution was ae to the minus x. So finally we're going to write the solution. So we're going to write the solution right here. So y, which we know was ae to the minus x plus b e to the 2x. Tell them that this is question number 6. That's going to be equal to what we said was a, this was a, and this is being multiplied by e to the minus x. Since the denominators are the same, look what I'm going to do. I'm going to factor out this denominator. So I'm going to write it as 1 over e to the minus 4 minus e squared into, I multiply now, e, because I have e over this, I multiply e times e to the minus x to get e to the 1 minus x. That's what you get, e to the 1 minus x. Plus, go ahead now, and you multiply b now, e to the minus 2 times this will become, e to the minus 2 times this will become e to the 2x minus 2. So this is the solution. That's the answer. Soft, a capital T. Tell them soft. Tell them soft. Too easy. Tell them soft, a capital T. Capital T. Soft. So this concludes 2019 paper. 2020 doesn't have any paper due to COVID reasons, but I wish you the very best practicing for your exam, and say it with me, K math is nice and easy, soft.